Hello my dear students, good evening all. How are you? Welcome to the session. How are you guys? Can you able to hear me? Give thumbs up in the chat box. Hi students. Hello, can you able to hear me? Yes. This is Suresh Avari, Faculty of Chemistry from Infinity Learn by Sri Chaitanya. Today we are going to learn about general organic chemistry decoding hyperconjugation. We have so many electronic effects. What are electronic effects here? Inductive effect, electromeric effect, mesomeric effect and hyperconjugation. These are the major electronic effects. In today's class we are going to talk about hyperconjugation. So what is the agenda of today's session? First of all, we will be talking about the details and the requirement conditions for the hyperconjugation and how hyperconjugation works and what are the applications of hyperconjugation and what are the other electronic effects that mingle with hyperconjugation and gives the exact opinion of a particular property. So all students, hi. Just can you able to hear me? Just put in the chat box, thumbs up, fiery emojis. Come on. Right? Come on. That's good. So what you learn in today's session? So perfect plan, hyperconjugation and conditions for hyperconjugation and alpha carbon. So key point in identifying hyperconjugation is finding alpha carbon and alpha hydrogens. I will tell you a simple trick to find out number of alpha hydrogens and alpha carbons and hyperconjugation structures. And in that, just see applications of hyperconjugation and electromeric effect and comparison of electronic effects like inductive effect and mesomeric effect and hyperconjugation effect, and these three are also mixed here. Okay, why late? We directly go and dive into that. Okay, hi Siro, hi Bharat, come on. All students, just give it fiery emojis. Santan Paul, Mrityunjay sir is there. I am also here. ठीक है? आपको हम पेश रहे हैं हाइपर कॉन्जुगेशन आज का. ठीक है? So hyper conjugation. What is hyper conjugation? Just see. It is a sigma and pi conjugation. So in that it is also called as no bond resonance. Why it is called no bond resonance? There is no bond but resonance is happening. I will tell you a simple story. If music is on, a child is dancing, a kid is dancing, we can say simply is active. If music is not there, still the child is dancing, you can say he is active, not only active, hyperactive. Right? That's what we are saying. So resonance is happening, conjugation is happening, even without bond. So it is a hyperconjugation. Conjugation क्या? Resonance का है. This is also called as Baker-Nathan effect. You can also say it is sigma and pi resonance or sigma and pi conjugation. So why I am giving this much emphasis on this? Especially the students who are preparing for competitive examinations, the organic chemistry, they are having a great phobia because they are lacking maybe proper utilization of the basics. So this is one basic that impact the total alkene stability, the properties of alkenes and carbocations and carbon free radicals. सर अगर आप कार्बन फ्री रेडिकल, कार्बन कैटायन एंड अल्कीन में आपको कमांड इतना होगा, ऑर्गेनिक केमिस्ट्री आधा कर सकते हैं. Therefore, I have taken for today's class hyperconjugation. है ना? So let's talk about what exactly this delocalization and how it happens. First of all, let's see the polarization. So, it is found in alkenes. Let us say this is a carbon, and this carbon is sp3 carbon. It is having hydrogens that are bonded, and this carbon that is attached to the carbon of double bond is called alpha carbon. It is simple and actually hyperconjugation लगता है बहुत complicated concept है, लेकिन I am going to give you this concept as simple as possible. You know, this is the hydrogen, एक छोटा सा atom है. The bond between this carbon and hydrogen is so weak, हल्का सा. This can be broken at any time because of the small size of hydrogen atom. It has lot of vibrations. Because of this vibration, ये bond कहीं भी तोड़ सकते हैं ना? Are you getting or not? Therefore, what happens here? This is going to be carbon, double bond, carbon. This is alpha carbon. And whenever this bond is broken, a positive charge आ चुका. Now a carbon ion क्या जैसे है, this carbon ion that is formed, actually carbon ion won't be formed. When the bond is broken, तुरंत ये resonance में घुस जाएगा, and the bond is going to replace it here, and this phenomena is known as hyperconjugation. You can see this bond again will come here. This phenomena can happen. What is this bond actually? The orbital के बारे में देखता हूँ. कार्बन टू कार्बन, बच्चों अच्छे तरफ देख लो. Here कार्बन टू कार्बन, दिस इज sp3 कार्बन बोल रहे थे आपको, है ना? अगर कुछ डाउट है ना तो पूछ लो. You please ask me in the chat box. This is sp3 hybrid carbon and it is bonded, and this is called sigma bond. This is called sigma bond, and this hydrogen, let it be here. And there is a pi bond. Pi bond means how it is appearing. A pi bond आपको देख रहा है ऐसे. There is a parallel overlapping. So this is called pi bond. Now pi bond and the sigma bond नजदीक में है. Now this sigma bond is going to overlap with pi bond, and this overlapping is known as hyperconjugation. That's what we have seen. This is also called as Baker-Nathan effect, sigma and pi resonance. Are you getting or not? Give thumbs up. Shanthan Paul, come on. Ha, great. Okay, come on, let's go ahead with the details of hyperconjugation. उसमें आप क्वेश्चन भी देख लें. Conditions for hyperconjugation. Condition for hyperconjugation is the major one. So condition for hyperconjugation is required to identify whether hyperconjugation होता है नहीं होता है. So it is always happens when p orbital or anti-bonding pi orbital. That's what we have seen. The carbon to carbon double bond is bonded with the pi bond of and the sigma bond of the next carbon. So how to identify that? That is called alpha carbon. That alpha carbon we have to pick. When the structure is seen, we have to pick it, right? Right. So there should be a presence of at least This is what you call the key point in the entire hyperconjugation. There should be at least one alpha hydrogen at the saturated carbon. That's what we have seen. This is carbon. So this carbon is called alpha carbon, and this alpha carbon should contain at least one hydrogen. Are you getting or not, children? Any doubts? Come on. Zero. Bharat? So I can see. Right. So how to identify the alpha hydrogens? The carbon atom that is directly bonded to an atom or a group or a functional group, anything that is attached to a group, that carbon is called alpha carbon. This alpha carbon is essential for hyperconjugation. So if you take this particular carbon chain, this carbon chain contains a system. The system can be a double bond or a triple bond or any functional group, and the immediate carbon you can name it as alpha. This is not according to IUPAC rule beta, right? This is not according to IUPAC. ये सिस्टम का हिसाब से ये पहले जो कार्बन एटम है ना, ये अल्फा बोलेगा, इसका बगल वाले बीटा होता है, ऐसे गामा एंड डेल्टा, समझे? सो जो भी हाइड्रोजन अल्फा कार्बन एटम्स के लगा हुआ डायरेक्टली, दैट इज कॉल्ड अल्फा हाइड्रोजन्स. सो अ सिस्टम कैन बी एनीथिंग, दैट एनीथिंग कैन बी ए फंक्शनल ग्रुप और कार्बोनायन, कार्बोकैटायन. इट कुड बी लाइक दिस. अब मान लो ये कार्बोकैटायन दे रहा है आपको CH3, CH2 एंड CH2 प्लस. ये सिस्टम का अल्फा कार्बन एटम कहाँ है? ये पॉजिटिव कार्बन का हिसाब से इसका बगल वाला जो कार्बन है ये अल्फा कार्बन बोलना है, और इट कुड बी एनीथिंग. सो लेट्स टॉक अबाउट दिस. आगे बढ़ेंगे. अल्फा कार्बन एटम पकड़ना कैसे? अल्फा हाइड्रोजन्स. जो हाइड्रोजन अल्फा कार्बन को सीधा बॉन्ड करेगा तो अल्फा हाइड्रोजन बोलना है ना? राइट. हियर द हाइड्रोजन एटम directly attached to an alpha carbon is known as alpha hydrogen, right? So carefully you see, this is a structure. So when you see a structure, आपको डर लग जाएगा, इतना बड़ा स्ट्रक्चर है, कैसे देखना एंड कैसे करना, लेकिन ये बहुत आसानी काम है बेटा. देखो एंटायर स्ट्रक्चर में, इन एंटायर स्ट्रक्चर में दिस इज अ कार्बन डबल बॉन्डेड. ये डबल बॉन्डेड के हिसाब से ये बगल वाला कार्बन है, ये अल्फा कार्बन होगा, समझे? सो ये अल्फा कार्बन का जो हाइड्रोजन्स है ये अल्फा हाइड्रोजन्स है, समझे बेटा? विशाल कुमार, ग्रेट. हाँ. नाउ दिस इज alkene system. Let us talk about the benzene system. In the benzene system, the carbon that is directly attached to the benzene is called alpha carbon, right? And the hydrogens that are attached here are called alpha hydrogens. आगे आएगा आपका कितना अल्फा हाइड्रोजन से सारे के सारे आप पकड़ना है. एक कार्बोकैटायन का स्पीशीज है. ये कार्बोकैटायन कार्बन विथ पॉजिटिव चार्ज, ये कार्बन के हिसाब से ये वाला होता है आपका अल्फा कार्बन. यू सी दैट पिन पॉइंटेड एनालिसिस इज रिक्वायर्ड. समटाइम्स व्हाट हैपन, स्टूडेंट्स गो इन द रॉन्ग वे. सो आई एम गिविंग यू द वेरियस क्लासेस ऑफ अल्फा कार्बन, माइंड इट, एंड द कार्बन एंड हाइड्रोजन, दीज आर अल्फा हाइड्रोजन्स, ठीक है? एंड दिस इज ए फ्री रेडिकल. ये फ्री रेडिकल कार्बन के हिसाब से ये अल्फा होगा, दीज आर अल्फा हाइड्रोजन्स, ठीक है बेटा? एंड दिस इज अल्काइन सिस्टम. ये अल्काइन के हिसाब से अल्फा कार्बन होगा, राइट बेटा? एंड जो हाइड्रोजन्स अल्फा कार्बन को सीधा लगा हुआ वो अल्फा हाइड्रोजन्स होता है. ठीक है बेटा, मैं आपको एक सवाल पूछना चाहता हूं, ये स्ट्रक्चर का हाँ, ये स्ट्रक्चर का कितना अल्फा हाइड्रोजन्स देख रहे हैं, फटाफट चार्ट में बोलो जल्दी। फाइंड द नंबर ऑफ अल्फा हाइड्रोजन्स इन द गिवन स्ट्रक्चर, फटाफट डालना है। आई एम जस्ट लुकिंग इन द चार्ट बॉक्स, हाउ मेनी, या यू कैन सी 9, ओके भरत, ऑलराइट, एनी मोर आंसर्स, कम ऑन, right, any more, Vishal, right, now you carry on with respect to this system. Carefully you see, this is what you call it as alpha carbon, and how many hydrogens are there with alpha carbon? This is actually a trap. Bharat, you correct yourself, right? Now you understand, Bharat? Come on, Vishal Kumar, your answer is correct. Bharat, so with urgency you have given the answer, right? So there is no, actually people trapped in this way. This is a trap. Organic chemistry, आप आंसर करने का एक तरीका होता है, ये तरीका सीखने का कोशिश करो चिल्ड्रन, ठीक है। दिस इज द एक्चुअल सीक्रेट इन द ऑर्गेनिक केमिस्ट्री। ऑर्गेनिक केमिस्ट्री कैसे करना है, कौन सा बुक करना, एनसीईआरटी करना और अरिहंत करना और द डिफरेंट मटेरियल्स में करना है और इंटरनेट में करना है, नहीं, एक ऑर्गेनिक केमिस्ट्री आप पकड़ने तो देयर शुड बी ए स्टाइल, है ना, देयर शुड बी ए वे। अल्फा कार्बन कहाँ है, अल्फा हाइड्रोजन कहाँ है, फंक्शनल ग्रुप कौन सा वाला देख रहे हैं, या कीटोन देख रहे हैं और आल्डिहाइड देख रहे हैं। कीटोन आल्डिहाइड एवरीबडी कैन से, बट समवेयर C डबल बॉन्ड O and OH is given, it is a carboxylic group, but you claim it is in a different way. You better understand the structure, that is the best way. समझ में आ रहा है क्या बेटा भरत? राइट, आगे बढ़ेंगे, थोड़ा क्वेश्चंस भी है आपका, है ना, चलो। Yes, Bharat corrected finally. That's good. Okay, come on. In case of the following compounds, there are 4 sp3 hybridized carbon atoms attached to this. Right? This is carbon with a positive charge. The carbon of alkene is a carbon of alkene, है ना? In this carbon of alkene, 4 alpha high carbons are there. हर अल्फा कार्बन एटम्स का 3 हाइड्रोजन से, सो 3 into 4 is equal to 12 अल्फा हाइड्रोजन है। आपके पास जितना अल्फा हाइड्रोजन से उतना हाइपर कॉन्जुगेशन होता है, उतना हाइपर कॉन्जुगेशन उतना स्टेबिलिटी भी आते हैं। सो स्टेबिलिटी इज डायरेक्टली प्रोपोर्शनल टू हाइपर कॉन्जुगेशन ऑफ द alkene. If you see here 12 alpha hydrogens, that's what it is explained, but in the book or in the examination or the question, this kind of structures will be given. You need to decode the kind of structures. Right, so आगे बढ़ेंगे। Based on the calculation of alpha hydrogens, we'll see, calculate the number of alpha hydrogens in the given compound. फटाफट करके दे, this is your question. Right from basic I am going here. I know you can do it, you're all good students, right? Yes, that जोश का है, come on. So how many alpha hydrogens are there? 6. Okay, great. Vishal, come on. Very good. राइट, विल सी। ये कार्बन का हिसाब से ये कार्बन अल्फा होगा, ये कार्बन का हिसाब से ये कार्बन अल्फा होगा। नाउ आप करेंगे तो ये अल्फा कार्बन एटम का 3, ये अल्फा कार्बन एटम का 3, 6 अल्फा हाइड्रोजन्स आर देयर, बट उसमें ट्रैप कहां है? ये अल्फा हाइड्रोजन नहीं है। Again I am telling you, hydrogen that is attached to alpha carbon are called alpha hydrogen. ठीक है बेटा? Now calculate the number of alpha hydrogens. You can see one more question beta. So there is no rigid condition that primary, secondary and tertiary carbocation will have always 3, 6 and 9 alpha hydrogens respectively. Why? Because they may have, if you see CH3, CH3 and CH3, 6 alpha hydrogens, you know, this is a tertiary carbocation. The same tertiary carbocation I would like to take कितना अल्फा हाइड्रोजन्स है? ममता शाहू, इट्स ए इंग्लिश क्लास, सो बोथ हिंदी एंड इंग्लिश इस्तेमाल किया जाएगा। ओके, डोंट वरी अबाउट दैट, फोकस ऑन द कॉन्सेप्ट। ठीक है? So here 3, 2, 3, 3 plus 2, 8. That is the meaning of the statement, right? Let us talk about hyperconjugation in carbocation. The hyperconjugation in carbocation, that's what it is saying. Carbocation means carbon with a positive charge. This carbocation, the hydrogen atoms that are attached here will participate in the carbon CH3 and CH2 plus. So let us see the hyperconjugation structures that are given to this. So carbon, hydrogen, hydrogen and hydrogen, and this is your carbocation, and there is no bond resonance. This simply comes as a Lewis structure here, and it gives you C, and there is no bond. So what happens here? Whenever the charge is here, it is unstable and it has a high energy. Stability is inversely proportional to the energy. When the bond comes over here, this charge is neutralized and the charge is going somewhere. Charge is moving one place to another place, that is called delocalization of the charge. Due to delocalization of the charge, it is getting stabilized, so that it comes like this. So और एक स्ट्रक्चर आपका आएगा H plus double bond CH2, like that. So you can see the moving around the charge here and there and gives you the stability. And moving ahead, hyperconjugation in ethyl carbocation, you can see various structures, that what is happening. CH3, CH2 plus, this is called ethyl carbocation. This ethyl carbocation, this structure comes here, this bond is shifted so that the sigma bond that is present here interacting with the pi bond. You can see this is your sigma bond and this is a p orbital and it is interacting. So there is no bond, but लेकिन resonance आ रहा है, resonance आ रहा है. So the charge is delocalized. Therefore this carbocation is getting stabilized. So this is carbocation stability is governed by hyperconjugation, and this hyperconjugation gives the stability for carbon free radicals as well. Because of the hyperconjugation, the bond is moved here and there. Therefore bond order decreases. So the bond order changes from 0.75 to 1. So the bond order is decreased. Therefore, based on hyperconjugation, you can say, in hyperconjugation, which of the following orbitals overlap? Come on, it's a question for you. Fatafat kar la. What are the orbitals that are participating? Yes, answers please. Ishita, you said 6. I am not asking you to count it. Have given ABCD options. Here sigma and pi orbitals or sigma and p orbitals are going to overlap. That's what is happened in the previous slide that I have shown you. You can see this is a sigma bond and this is a pi, and these two are going to overlap, hai na? Yes, that's great, that's great. P and p orbitals nahi beta. Now it is going to be sigma and p orbitals, because in hyperconjugation the delocalization of sigma electrons with vacant p orbitals or pi orbitals takes place. Fine? S and p, right? That's good. Bharat, good. So Abhijit, you correct yourself, right? Fine. Next, ethyl free radical and ethyl carbocation hyperconjugation is same, but the difference is here ethyl free radical homolysis takes place. Look at here, this is a pair of electron. In this pair of electron, this is how a new structure is formed. Let it be in this carbon, hydrogen or that carbon, right? So again hyperconjugation happens in ethyl free radical as well. So these are the number of alpha hydrogens, 3. So the stability of the molecule, again I am telling, the stability of the molecule is based on the number of hyperconjugation structure. अगर ए स्पीशीज को जितना अल्फा हाइड्रोजन होगा उतना hyperconjugation structures होगा, and the stability also follows the same. Got it better? Right. Now, can hyperconjugation occur in the case of carbon ions? This is a very good question. Carbocation में देखा, carbon free radical and alkenes, in these 3 species hyperconjugation is seen, but carbanion में होता है नहीं. Carbanions are sp3 hybridized, therefore there is no unhybridized p orbital, therefore no hyperconjugation. You simply say big no for hyperconjugation for carbanions. That's very, very important. Clear? Any doubts? You please ask, feel free to ask in the class, children. Ishta? Kabijit, come on. So moving ahead, in alkenes sp2 hybridized carbon is more electronegative than sp3 alpha carbon, so delocalization of electron could takes place from alpha carbon to alpha hydrogen, right? That's what is happening. So this is carbon double bond and this is alpha carbon, so that it is going to participate in hyperconjugation like this. Checking the alpha carbon and the alpha hydrogen is essential state here. Now, alpha hydrogen is seen in toluene. What is toluene? What is toluene? It is a methyl benzene, right beta? This methyl benzene has alpha hydrogen. This alpha hydrogen gives the electron here, so that there is no bond resonance can happen. As a result of this hyperconjugation, toluene negative charge is accumulated at here, at here, at here. What are these positions? Ortho, para, फिर भी ortho. That is the reason why the toluene, due to positive hyperconjugation क्यों बोल रहे? Electron is given to the conjugated system, that is called positive hyperconjugation. Due to positive hyperconjugation, it is going to be ortho and para director. Ortho and para director in electrophilic aromatic substitution. And moving ahead, hyperconjugation also explains the stability of carbocations, free radicals and alkene. As the number of alpha hydrogens increases, मैं बोल रहा हूँ, the number of hyperconjugation structures increases. So the stability is directly proportional to number of hyperconjugation structures, is directly proportional to number of alpha hydrogens. This is the entire secret of the hyperconjugation phenomena. Now deuterium can also show hyperconjugation like hydrogen. If deuterium is there, it can also show hyperconjugation. That is one more secret. And since the carbon to deuterium bond is stronger, so whenever deuterium is there, hyperconjugation थोड़ा slow होगा. Understand better? Right. Now comparison of electronic effect and we'll see after this. Okay. Applications of hyperconjugation effects. Hyperconjugation effects: stability of alkene, heat of hydrogenation, and stability of carbocation and stability of carbon free radicals. So let's see. First, stability of intermediates. What are the intermediate you see? Carbocations you can see, carbon free radicals you can see, right? And heat of hydrogenation and bond length and stability of intermediates. And I am going to show you everything. Example, the stability of carbocations and free radicals is directly proportional to the number of alpha hydrogens. यहाँ देखो, ये structure A का 3, 9 alpha hydrogens are there, right? And the structure B का 3 and 3, 6 alpha hydrogens are there. And the structure C का सिर्फ 3 alpha hydrogens are there. And a structure D का 0 alpha hydrogens are there. Now the hyperconjugation A is greater than, B is greater than, C is greater than D. समझे? And the stability A is greater than, B is greater than, C is greater than D. That is how simply you can answer these questions. However, any examination it is given. Any examination, a structure is given, simply pick the number of alpha hydrogens and give the order. That's it. Now, if a tertiary butyl carbocation, there are 9 alpha hydrogens. Tertiary butyl carbocation means this is tertiary butyl carbocation. Structure भी पता होना चाहिए. And isopropyl cation means B, the previous slide. And this is ethyl carbocation, methyl carbocation. The stability order goes like this. The same thing you can see in the free radicals as well. Got me? Right. Hi Bharat. Right. Now, free radicals also same with respect to this A 9 alpha hydrogens, with respect to this B 6 alpha hydrogens, with respect to this 3 alpha hydrogens, 0 alpha hydrogens. So that again A is greater than, B is greater than, C is greater than T. These are all free radicals. The stability of free radicals and stability of carbocations, the order is the same, right? Coming to heat of hydrogenation. What is heat of hydrogenation? When alkene is subjected for addition of hydrogen, heat is liberated. 1 mole of alkene, you can see 1 mole of given compound, it is the enthalpy change or heat liberated. It is an exothermic process. It is the heat liberated when 1 mole of alkene is hydrogenated, is called heat of hydrogenation. It is an exothermic process. And this heat of hydrogenation is inversely proportional to stability. More the stability of alkane, इसका कम heat of hydrogenation होगा. If you check, this is an alkene. When hydrogen is added, 2 double bonds are there. You can see enthalpy of hydrogenation minus 60.8 kilocalories. If you consider this alkene, if hydrogen is added, minus 28.5. If this alkene, hydrogen is added, minus 30. So what are the points we are going to learn from here? In this alkene, more number of double bonds are there, therefore more heat of hydrogenation is seen. And one more point, here only 1 double bond is there, so we are getting into the details of alkenes, right beta? So 1 double bond is there, agar hydrogen is added, 28 minus 28 is given, minus 30 is given. So why here it is minus 28, why here it is 30? Because this has only 1 alpha hydrogen, only 1 alpha hydrogen. इसका 5 alpha hydrogen, 5 alpha hydrogens का वजह से इसका ज़्यादा stability होगा. 5 alpha hydrogens means 5 hyperconjugation structures. 5 hyperconjugation structures means more stable. More stable means less heat of hydrogenation. Whereas this has only 1 alpha hydrogen. So this is methyl. So it don't have alpha hydrogen. So that it is going to give more. So to identify the heat of hydrogenation of alkene, I am giving you the key point. Heat of hydrogenation निकालने के लिए पहले ये point consider करना पड़ता है बेटा. First, number of double bonds or number of pi bonds. जिस compound में pi bonds ज़्यादा है उसका heat of hydrogenation ज़्यादा होगा. If number of pi bonds are same, you have to consider the second point and third point. Second point and third point are same. So please note here, if number of If number of pi bonds are same, second point इस्तेमाल करना है. ठीक है बेटा? This is a key point. You can answer many questions based on this. This is a key point. Note कर लो बेटा. Very important point. So far, based on this particular key point, so many times, so many examinations, so many questions are coming. Come on, let's do a question. Compare the heat of hydrogenation of the given molecule. So, if this question is done, hyperconjugation, we are coming to an end. Compare the heat of hydrogenation of the given molecule. So, let's recall what we learned. Heat of hydrogenation inversely proportional to stability. But stability is directly proportional to number of alpha hydrogens. So let's see how many alpha hydrogens are there. Structure A, how many alpha hydrogens are there? फटाफट बोल दीजिए. Come on. गर्वित वर्मा, come on. Structure A, find out. A कार्बन के हिसाब से A अल्फा होगा ना. A कार्बन डबल बॉन्ड के हिसाब से अल्फा होगा. A अल्फा होगा. फिर भी A अल्फा होगा, है ना. Picking alpha hydrogens, key point. So valency like this, like this, है ना. Like this, how many are there? हर structure का निकालना है. This structure A contains 3 plus 3, 6, 7, 8, 9, 10. Like that, if you calculate, pick out the alpha carbons now. This is alpha carbon, this is alpha carbon, and this is alpha carbon. Carbon that is immediately attached to the carbon of double bond. And this carbon के हिसाब से this is alpha carbon and this is alpha carbon. समझे? Got it बेटा? And एक double bond के हिसाब से A alpha carbon, A alpha carbon. बस. So first rule, pick the alpha carbon. Second, pick the hydrogens, alpha hydrogens. And the third, count the alpha hydrogens and write the order of stability. You can see. Now, in case of A, there are 4 alpha carbons and 10 alpha hydrogens like this. In case of B, there are 3 alpha carbons and 6 alpha hydrogens. In case of C, there are 2 alpha carbons and 4 alpha hydrogens. Like that you can write completely. And in case of D, there are 2 alpha carbons and 3 alpha hydrogens. इसमें सिर्फ एक ही अल्फा हाइड्रोजन होगा. देखो कार्बन टेट्रावैलेंसी के हिसाब से. ठीक है बेटा. एंड इफ यू चेक 10, 6, 4, 3, based on that the stability order and the heat of hydrogenation order is going to be ulta. Sometimes we solve the entire question सही करते हैं लेकिन गलत आंसर पकड़ लेंगे. That is a wrong thing. So you can see 10 alpha hydrogens are there in the compound A, 6 alpha hydrogens, 4 alpha hydrogens, 3 alpha hydrogens, that is given here. As the number of alpha hydrogens increases, clearly you can see the slide, the stability of alkene increases, therefore the heat of hydrogenation decreases. So number of alpha hydrogen and stability order A होगा, A greater than B greater than C greater than D, and the heat of hydrogenation follows the reverse, D greater than C greater than B greater than A. ठीक कमाल किया आप लोग. Acha? So this is how hyperconjugation helps us in deciding stability of alkene as well as carbocation and carbon free radical. Dear children, this is the end of the hyperconjugation. From this concept, I can assure you that you are able to do so many questions from hyperconjugation related alkenes and carbocations, carbocation stabilities and the heat of hydrogenation from any examination. So hope you enjoyed today's class. So nice interacting with you guys. So give big thumbs up and like and share the session. Okay. Thank you very much. God bless you all. Bye bye.